Hey guys, for part 2 of our project, we will discuss Grace Hopper's impact on computer programming languages. For our presentation, we will be organizing this as follows. First, we'll discuss her personal background very briefly. From there, we'll discuss her major projects. First, her Mark I involvement, which is one of the first computers. Then UNIVAC 1, which was the first commercially produced electronic digital computer, and then her invention of Flowmatic, which was the first compiler which translated machine code into English syntax. And from there, we will discuss how COBOL, which was a programming language for non-computer scientists, built off of Hopper's work on Flowmatic, and we will conclude with Hopper's contributions to today's programming languages in terms of readability and machine independence. And we will also consider her involvement with the origin of debugging. To start things off here, she was very curious as a child. At 7 years old, she figured out how to reassemble a destroyed alarm clock after destroying several. And this really showed her curiosity, which really helped her in her path in academia, up to a PhD in math from Yale. And this also helped her work her way to becoming an associate professor in math at Vassar. But then World War II happened and changed her path tremendously. Because of this, she wanted to enter the Navy, but she was rejected because she was not the most physically suited, and her job as a mathematician made it too valuable for her to leave. But thanks to her persistence, she eventually was given temporary leave, and she was able to join the Naval Reserve, and she quickly adapted to the rigor of Navy training. After going through this training, one of her first assignments was working on Mark I, and she served under Dr. Howard Aiken, who was a Navy commander at Harvard University. The purpose of this project was to expedite solving advanced problems in math and physics. This was a big computer, as you can see from this picture, and it involved punch cards and moving mechanical parts. And it was a very big computer, unlike what we have today. The applications were plenty for the military. Among them were gunnery, ballistics, and design problems for advanced math and physics. Hopper would go on here to work at Harvard as a research fellow, and she would not return to her old job as an associate professor. But then she became a senior mathematician to help work on UNIVAC 1, which was the first commercially produced electronic digital computer, and its main claim to fame was accurately predicting the 1952 United States presidential election, where it used only a 1% sample to correctly predict that Eisenhower would win, going against the grain of the common belief that the other person would win, but the other person ended up losing. But more importantly, in this job, she realized something very big, was that people who had no knowledge of computers could not learn how to program because of the complex code, and this was termed machine code. It just could not be understood at first glance whatsoever. So Hopper's goal became to have a computer be able to read programs that are more so in English syntax. But then, this syntax would be translated into the machine code for the computer. This led to her invention of Flowmatic, which was the first compiler of its kind, and this transformed machine code into code which is easier for humans to read. And this idea was not accepted at first glance. Hopper herself said nobody would touch it, and they told me computers could only do arithmetic, so they were very skeptical. Hopper also said that manipulating symbols was fine for mathematicians, but it was no good for data processors who were not symbol manipulators. From this invention, though, also came something even bigger. So from Philmatic, she helped with the creation of COBOL, which is known as the Common Business-Oriented Language. So it was created by the U.S. Department of Defense for business use, and it's created by a committee of computer scientists. And COBOL was pretty much the very improved version of Philmatic because it can be used in many different ways. And Hopper was the technical consultant in this project of making COBOL a thing. And it meant for an audience of a lot of non-computer scientists because the syntax was easier to follow, and it's pretty much an extension of the Philmatic where it is used in many different industries, not only just pure computer science. And because of her contribution to COBOL, Hopper earned the nickname Grandma COBOL. She also helped with the standardization of COBOL, and in 1967 she rejoined the Navy to work on standardizing COBOL because back then each company has different version of COBOL, and her work helped to consolidate all different types of versions of COBOL into one universal COBOL that can be used for many different computer types. Grace Hopper had a lot of contributions to today's programming languages, and the big thing today is readability and also machine independence. So pretty much today all the different types of programming languages are easily readable, and people are encouraged to code in a way that is easily readable so it can be used for debugging or testing purposes. And also today's programming are very machine independent, where a single program can be used in run across different computers, and it solves a lot of incompatibilities. And for readability, here is a code from the LMC that's taught in the class, and you can see that not only is the code a lot longer than the one on the left, which is in Python, the assembly code is also harder to read. For those who have not been trained in assembly code, you have no idea what that is, but for Python you can see that you're returning simply the max of two numbers. It's very simple. Also, her contribution helped with machine independence, where initially programming languages were depending on the type of computer, but now with the rise of COBOL, her idea of machine independence was spread to many different types of programming languages after that. And this property that's pretty much taken by granted for modern programming languages, and it also helped with the computer science education, as we only need to teach one type of code and that can be worked on different types of machines instead of the need to teach for a specific machine. So now we have a trivia about Grace Hopper, and originally the programming bug was actually a bug that was found in the relays of the Harvard Mark II computer, and the bug is now stored in Hopper's logbook as shown in the picture on the right. And this led to the term of bug and debugging that's in the context of computer science. And thanks for watching our video.